In this video, we're going to be talking about combining like terms and then combining like terms so that we can solve equations. So I want you to take a look at the screen and I want you to look at every single term that you see in front of you. Do any of those terms look like they are like terms? Now, in order for terms to be considered like terms, you have to have the same variable raised to the same power. If you look at the first one, 4xy, this power for x is 1, the power for y is 1 because you see a variable, but there's no exponent. So there is technically a 1 there. In the second one, this is 3x squared y. So these two so far that I have in blue, they are not like terms. The first one is just 4xy and the second one is 3x squared y. So even though they both have an xy, they are not like terms because the 4xy is not 4x squared y. If we had 4x squared y, for example, plus 3x squared y, then yes, those are like terms because you have x squared and y. And so when you add them, you just combine like terms and that becomes 7x squared y. So the variables and the powers, they don't change. You really are using what's called the coefficients. The coefficients are the numbers in front of those variables. And so here 4 plus 3 is 7. So you collected like terms. You combined like terms. So let's continue looking at the rest of the terms. The third one, 5xy squared, is also not a like term to the previous two because 3x squared y has the square with the x, but 5xy squared has the square with the y. So they are not like terms. If I continue down, I have x squared y squared. When you don't see a coefficient, and if you remember what I just said, the coefficient is the number in front of those variables, then right here, the coefficient really is 1, okay? But still, nothing else has x squared y squared, so these are not like terms. So far, none of the ones that we've looked at are like terms. All those in blue right now, they're all different. None of them are like terms. Let's keep going down to the last two. 6x squared yz. This is the first time we see a z in the term. Obviously, it's going to be different than any of the other ones that we have in blue. So this one's also not a like term. It's different. And then the last one says 3xyz. And even though I have an x, a y, and a z, like the previous one, the one that is 6x squared yz has x squared, and this one does not. So again, none of these right now in front are like terms. Let's use the terms that we actually have here so that we can set up a problem so that you can start figuring out which ones are like terms and can be combined. So let's say hypothetically the question says 5xy squared plus x squared y squared minus, let's say, 3xy squared plus 7x squared y squared plus 5xy. So let's say this is the problem you're working with. When you look at the problem, the first thing you want to do is collect or combine like terms. So you want to look for those that are exactly alike. Take a look at your screen. Can you figure out which ones are like terms? If you answered 5xy squared and negative 3xy squared, you are correct. Those are like terms. Positive 5 and negative 3 is going to give me 2. 5 minus 3 is 2. And then I write xy squared because those are the variables and exponents that we have. What else are like terms? If you said x squared y squared and 7x squared y squared, you are correct. And if you remember, there is a 1, a coefficient of 1 in front of the x squared y squared. So here, 1 plus 7 is going to give me 8, and then I write x squared y squared. Then the only term that we haven't taken care of yet is this 5xy. But 5xy is not like terms to anything else that I see in front. So what do? I just have to add it to my answer. Plus 5xy, and then this is your final simplified answer after combining like terms. Let's go ahead and look at some examples. Directions. Simplify by combining like terms. So in question number 1, we have 5x. Here I have plus x. Those are like terms. 5x and then x are like terms. Remember, the x has a 1 as a leading coefficient. So positive 5 and positive 1 is positive 6x. Then I have negative 4y, negative y. Again, when I don't have a coefficient, the coefficient is 1. A negative 4 and a negative 1 is negative 5y. And then the only one that I haven't combined yet is 2xy, which is different than the other two that we have, 6x and negative 5y. So I just bring it down, plus 2xy. Go ahead and do number 2 by yourself. Pause the video. In this case, we also have like terms. 8ab and negative ab are like terms. There's a 1 in front of that ab. So 8 minus 1, the answer is 7ab. And then negative 4a squared plus 3a squared, they are also like terms. Negative 4 and positive 3 is negative 1a squared. And it's not necessary to write the 1 because it is understood when we see the a by itself that it's there. Do I have to write it in this order? No, perhaps you started with the terms that I circled, so your answer would have been negative a squared plus 7ab. These two answers are exactly the same. Hopefully you got it right. In number 3, we also have like terms. 11m minus 4m is 7m, and 6mn minus 1mn is positive 5mn. And those two are no longer like terms, so you have to leave the answer as is. In question number 4, we have negative 20x squared and positive 12x squared. Negative 20x squared plus 12x squared is negative 8x squared. And then I look at what I have left. I have 18x, but there's nothing else that has an x. And then I have negative 10. So these are different. So I'm going to write plus 18x minus 10. None of those now are like terms, so that is my final answer. We're going to take this a little step further, and now what we are going to do is actually solve equations, but first we're going to combine like terms on the same side of the equal sign. So in number 5, 6x minus 4x, yes, these are like terms. So I get 2x is equal to negative 28. Now this is easy. Divide by the number that's next to the variable. Divide by 2. So x equals negative 14. And that's my answer. So in number 6, we have an equation and we have parentheses. So I'm going to start by distributing. I'm going to write negative 27a. Distribute again, plus 12b. Because of the parentheses, see how the parentheses ends right here, I do not keep going negative 3 times negative 5. No, 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 you do not do that, okay? Wherever the parentheses ends, that's as far as you go. Instead, what I'm going to do is bring down the rest of the problem. Negative 5a minus 12b is equal to 64. And now I can go ahead and check for like terms. Be very careful about not doing too much at one time. Sometimes my students, they try to get so ahead of themselves by taking shortcuts that's where they lose themselves and they make mistakes. So it's better for you to distribute first, and now let's go ahead and combine like terms. So here, negative 27a and negative 5a are like terms. positive 12b and negative 12b are like terms and they're on the same side of the equal sign, so I'm combining them. I notice that positive 12 and negative 12, they're just going to cancel because 12 minus 12 is 0. So I can just get rid of them already. So that means that I have negative 27a and negative 5a is negative 32a is equal to 64. So now I'm ready to solve for a. I'm going to divide both sides by negative 32. So a is equal to negative 2. And voila, that's my answer. In question number 7, again, on the same side of the equal sign, you can start off by combining like terms. Positive 30 and positive 12 gives me positive 42. Negative 5x and negative 8x gives me negative 13x is equal to 16. Now that I've combined like terms, I have to solve this equation. I'm going to subtract 42 from both sides. I get negative 13x is equal to negative 26. Divide both sides by negative 13. So x is equal to positive 2. In question number 8, I have parentheses once again, and I have a fraction, which is fine. I'm going to go ahead and distribute. So 1/2 of 8a is equal to 4a, and 1/2 of negative 4 is equal to negative 2. That's the end of distributing. Let's bring down the negative 2a is equal to 16 minus a. I'm going to combine like terms on the left side of the equal sign. Because the equal sign is right there, okay, we're only going to combine like terms to the left of the equal sign right now. So 4a minus 2a is going to give me 2a. So I get 2a minus 2 is equal to 16 minus a. And now be careful because you are no longer combining like terms right now on the same side of the equal sign. You have this equal sign right here, and now you have to solve. So if you'd like to keep the variable on the left-hand side of the equation, I'm going to go ahead and add a to both sides. That cancels it on the right. I get 3a minus 2 is equal to 16. Now we're going to add 2 to both sides. So we get 3a is equal to 18. Divide by 3. A is equal to 6. So now we were able to solve for the variable. The first thing we did was distribute and combine like terms. In question number 9, here's my equal sign. To the left of the equal sign, I do not have like terms. To the right of the equal sign, I don't have like terms. So I just have to solve. So here, if I want to, once again, keep the variable on the left-hand side, I'm going to subtract 2x from both sides. I get 20x minus 10 is equal to 30. Now that I move the x's to the left, I can move the 10 over to the right-hand side, and I get 20x is equal to 40. Divide by 20. So that means that x is equal to 2. 40 divided by 20 is 2. Finally, in number 10, we have negative 4y plus 7 over 2 equals 5. Fractions, okay? Don't get discouraged because of the fraction. Again, on the left-hand side, I do not have any like terms to combine right now, so it's an equation I'm getting ready to solve. To get the y by itself, I'm going to subtract 7 over 2 from both sides. And now I end up with negative 4y is equal to, let's take care of 5 minus 7 over 2. 5 is a whole number. I can write 5 as a fraction if I put it over 1. So now I have 5 over 1 minus 7 over 2. The least common denominator is 2. So instead of 1, I have to make this denominator 2. The way the 1 became a 2 is because I multiplied by 2. And whatever you do to the bottom, you have to do it to the top, so that becomes 10 over 2. So now I have 10 over 2 minus 7 over 2, which is 3 over 2. So I get negative 4y is equal to 3 over 2. Divide by negative 4, divide by -4, this cancels. Y equals 3 over 2 divided by -4, which is -4 over 1. When you divide by a fraction, it's the same as multiplying by the reciprocal. Keep it, change it, flip it. So y equals 3 over 2, change division to multiplication. What comes after to its reciprocal? 1 over -4. So then I'm ready to get my answer, which is 3 over -8. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.